we have 8 modules to promote understanding of the need for guardrails in managing AI risks. And the table of contents, if we look first into the diversity of AI, then we try to understand the AI risks, and then a little bit discussion about guardrails, what are they, and then we are exploring the principles of responsible AI and a little bit about the AI regulations also, and then a very short introduction to other modules. But let's first try to understand the diversity of AI. You can always take a different kind of lenses, and one lens is that you study AI from the roles of AI. For example, this supportive AI their AI has very clear assistive role, and that's very clear nowadays for everyone. And it's a tool to enhance expert work, and it acts there as a sparring partner or knowledge enhancer. And there the expert remains always accountable for how AI-generated information is shared and used. And there on the opposite side, we have this autonomous AI, full automation, where the AI performs tasks totally without human assistance. Or AI chatbots are like this, and this where the hype is now very, 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 very high, this agentic AI. It refers to systems that make independent decisions. They plan actions without human assistance. And these self-trained AI models, what we have been, for example, at Statistics Finland doing for years now. They are trained for specific purposes, and they are also autonomous, although they are not foundation models. And there in between, there's this collaborative AI, where the AI does the main part of the work, but there's still human in the loop who decides if the output of AI was correct or not. And the expert remains accountable for ensuring the correctness of AI-generated outputs. But you can also look at the AI from totally different perspective, because AI will arrive and arrives in many different packages. I borrowed a picture from a slideshow from Gartner because I thought this is really a good example, and it helps to understand the diversity of these packages it enters to your office. So on the right hand side, there's this green box, and there are these off-the-shelf applications such as Copilots, Power BI, ChatGPT, and so on. So where AI is embedded into software by vendors. And then the red box, bring your own AI box. There are solutions developed within the organization for specific needs. For example, by different departments, custom GPTs in ChatGPT platform are such things. And that also includes shadow AI. And that's also an AI which is totally without oversight. And then in the blue box, we have these in-house trained models or adapted foundation models. We are probably fine-tuning and so on. And in the blue box, there are also models embedded by software developers into the software. And as we can see that there in the middle, there's this circle that says that we should be able to coordinate and run and secure all this that comes into the office. And then there's another perspective, a third perspective. While AI may operate autonomously or collaboratively, the significance and the risks of its task must be assessed. And not all AI-driven actions, they don't carry equal weight or risks for the organization's core objectives. So task significance. So how critical is the task to the organization's core operations or goals? So low significance is AI drafting a standard email response. But the example of high significance is when AI is generating statistical outputs used in a national policy making. And there's a big difference between these two. But we also have to do risk assessment, where we try to identify the potential consequences when AI makes a failure. So what's the potential impact of AI failure in this task? You ask yourself this question. So examples of low-risk tasks. So again, automating document formatting and the high-risk tasks. What happens when AI editing data for official statistics makes a failure? There's a huge difference. So not all AI is created equal. So we may actually mean very different things, varying not only in function, but in significance, impact, and risks for official statistics. So it's very important that we recognize that AI also enters statistical offices very quietly, embedded in tools, platforms, and services. And we don't really know about these hidden risks when we are not aware that there is an AI. So I think especially producers of official statistics, we have to have context-specific policies and workflows that they reflect to the nature of AI task, its role in production, and the consequences of failure. And that would somehow ensure that the AI is neither over-regulated nor left unsupervised. And you have to find the balance here. And adopting AI, it is really balancing risks and benefits. And now, particularly generative AI at the present, it's fundamentally transforming all industries, not just statistics. It's offering groundbreaking opportunities and really on the other side, significant challenges. So the more organizations utilize AI to enhance their operations, the more risks arise. So I've somehow thought that it's like it can be compared to preparing pufferfish. If the preparation of fugu pufferfish goes wrong, the chef has to commit harakiri because it will poison all those people who ate that. So when producers of official statistics, when we utilize AI in our data production, we bear a full responsibility for the accuracy and accountability of the data we have generated, just the same way as a chef is responsible for the preparation of fugu. So, but we cannot always eliminate all the risks, but we can minimize risks and manage the responsibility while we are maximizing the benefits. Unfortunately, AI is a greatest power of cyber risks at the moment already. It's not only in the future. For example, an AI-powered chatbot with weak security can be manipulated through prompt injection attacks to leak sensitive information and many other things. So, and many identified AI risks are also cyber risks, but not all. Cyber risk is especially refers to digital threats where attackers deliberately exploit system vulnerabilities, data breaches, information leaks, and so on. So I think always that understanding AI before using it is a question of responsibility also. So when adopting it, we must understand what we are working with. So we just cannot take a black box such as generative AI is now and ask it to produce statistics for us. So the hype around generative AI has been immense, and as a result, it's not always clear what generative AI is really useful for, and where it's simply not mature enough yet. But one way to begin to understanding the opaque parts of AI is to look at through the lens of risk. And of course, as a producer of official statistics, what could be more natural than try to classify the risks? And why is AI risk categorization so important? Because thousands of AI-related risks, they have been already identified. But it is impractical to assess each one individually. So instead, categorizing these risks at a higher level, it helps us to understand it better. There is already such a living database called MIT AI Risk Repository. It's been generated by MIT researchers, and there are at the moment over 1,600 AI risks categorized by the cause and risk domain. And the causal classification tells you also how, when, and why these risks occur. So I really encourage the Statistical Society to explore and consider utilizing this AI risk repository. Really, it's a really good tool for identifying risks. I have picked up a couple of specific subclasses from this MIT classification. For example, this governance failure, it tells that there are very weak rules and oversight that can't keep up with AI progress, and that leads to poor risk management. And then this competitive dynamics, it means that rapid AI development is driven by competition, and that is increasing the risks of unsafe and faulty systems. But unfortunately, I have not had enough time to go through so in detail this taxonomy of MIT, but I've still used my own classification in this presentation, because there are a couple of things that are lacking there, and that perhaps I should have somehow made a combination of these two. because, for example, these ethical and societal risks and societal impact risks, which I call actually there in another slide, macro level risks, they are something that are a little bit lacking from that other classification, and many other researchers have also attempted to classify all these AI-related risks, and they can be really classified from multiple perspectives. I go through now the main classes of the AI classification I have made, but there are some. There's they at the risk side they use such a vocabulary that may be sometimes a little bit strange. For example, this prompt injection, it's a malicious where malicious actor manipulates an AI system prompts and that alters the model's behavior. And jailbreaking, it's where AI refers to bypassing safeguards to make an AI system generate prohibited and unintended outputs and so on. And there are, but perhaps if somebody wants to check more about this vocabulary, this presentation will be shared. AI systems, they often handle sensitive data, and that makes them really vulnerable to privacy violations, all kinds of data breaches and cyber attacks. So, and if there's a poor data protection, it increases these risks, posing threats to organizations and individuals. And I have some examples here, like this generative AI tools, they have unintentionally leaked user data, and that happened also to ChatGPT 2023, where there was a data breach where some users could see other users' chat histories and payment information due to a bug. And this was just a short example what can happen, what kind of privacy and security risks can really occur. And then these operational risks, they pertain challenges in maintaining the efficiency and cost effectiveness and the reliability of AI systems. It's about ensuring that the AI infrastructure remains controlled and predictable and maintains the efficiency and reliability. These operational failures, they can be such failures where the system starts to degrade, and reliance on third-party services can then lead to failures. And generative AI systems may be vulnerable to these denial of service attacks, which can make them temporarily unusable. And there are also resource dependency risks. For example, high cost and limited expertise can create dependencies on just few large technology companies. And then we have ethical and societal risks. And examples, I think these are most familiar to all statisticians. For example, this bias in training data. It can lead to unfair outcomes affecting groups on race, gender, or socioeconomic status. manipulation of society can be something like AI algorithms on social media platforms can amplify political polarization. And then this macro level impacts, societal impact risks. So it's not only the individual users AI can affect, it can also shape society as a whole. And these macro level risks include economic, environmental, even existential concerns. So example of economic risks that AI and automation can replace jobs, especially low skilled ones, and that can cause inequality. And at the same time, for example, new AI driven jobs, they require reskilling and retraining, and perhaps not everyone has access to it. And environmental risks, where large AI models consume a lot of energy and resources. My daughter always says to me when I answer, I check everything from ChatGPT, that don't use that ChatGPT, it will destroy our whole environment. And so I think the younger generation is already more aware of that. And then these existential risks. Some experts warn about uncontrollable super intelligent AI that could pursue goals that conflict with human values, and that can cause serious long-term risks to humanity. But these kind of risks have not occurred yet, but this is something that some researchers see that might happen in the future. And then explainability and transparency risk, although the responsible AI principles, explainability and transparency, they are in totally separate things, but in this risk classification, I've added them into one and same risk class. So they can make these lack of explainability and transparency can make it difficult for stakeholders to understand the whole decision-making process, and that really undermines the trust. So if stakeholders can't follow how AI works, trust and accountability suffer. So many systems are like black boxes. The logic is hidden or it's too complex to explain. So if we can't explain AI's role and decision-making process, I think people are less likely to accept and oversee its use. So output clarity is important, and generative AI models may produce fabricated or culturally inappropriate content. So complicating the whole explainability process. For example, is hallucinations in Gen AI outputs. They require still human review as their origins are often opaque. So that makes trust and validation really difficult. So decisions made by AI can be hard to understand and explain. And then functional and technical risks. This focuses on vulnerabilities and exploits within AI models and systems. And the risk category we had earlier, operational and reliability risks, focuses on practical management and resource dependency. So system exploits is an example where attackers can bypass safety measures using these prompt injections and jailbreaking methods. Should I call them methods, even though they are quite criminal methods? And they allow malicious users to make the system produce really unintended content. And model integrity risks are where over time the AI systems, they become less reliable. And the example of course, quite familiar for those data scientists is model drift, system accuracy declines, and the real world condition when real world conditions change. And other examples are data poisoning and other inconsistent behaviors. Legal risks, they arise from the regulatory and liability challenges that are associated with AI. There are copyright problems and with regulatory compliance, AI evolves faster than many legal systems. So that creates a confusion about who is responsible and what rules apply. And regulatory non-compliance, failure to adhere to AI-specific regulations, such as what we have now in EU's AI Act or GDPR, which is quite important here on the AI branch. So it can lead to legal penalties and restrictions. Organizations must actively follow legal updates. And then we come to these guardrails in the context of artificial intelligence. So AI guardrails, they are safeguards that ensure AI systems operate safely and ethically and operate so as they are intended to operate. So the term now covers a broad set of protections that help minimize and mitigate these risks. So they can be technical guardrails, they can be organizational guardrails, they can be ethical guardrails. And why these guardrails? Why do they matter? Because without these guardrails, AI can behave unpredictably. So guardrails ensure that AI systems operate safely, ethically, and minimizing these potential risks. Examples, MLOps and LLMOps, they are very practical guardrail frameworks. They include ethical and technical guardrails. So they provide tools and processes for managing AI through its entire life cycle. Responsible AI principles, they are more ethical guardrails. They guide AI to align with public values like fairness, explainability, and so on. And then we have AI regulations, they are legal guardrails. And then again, let's put these all things together. So there are these many kind of guardrails, and the goal of this whole project, or whatever I should call this, advancing responsible AI, is to build a network of guardrails to support the safe use of AI, especially, of course, in official statistics. So what does it mean in practice? So that you put the right guardrails into the right places. So strict oversight there where it's needed and no unnecessary restrictions where it's not needed. So guardrails protect core principles of responsible AI. And how do we turn the principles into guardrails? So that you identify risk is just the beginning. So these principles, responsible AI principles, they act as a guardrails only when they are not just words, but goals we actively commit to. So we need organization-wide commitment that we can put these principles into practice. And once the principles are set, the next step is to turn each one into concrete actions. For example, when we talk about transparency, MLOps can support it, but transparency, it requires governance structures and clear communication to stakeholders. And for example, when we talk about data protection and privacy techniques, we know like anonymization or pseudonymization, they help, but they are not enough without proper procedures and oversight mechanisms. So in other words, responsible AI principles, they become guardrails only when supported by practical tools, processes, and accountability. And then we have the principles of responsible AI. The naming and the division of responsible AI principles, it's not standardized. However, the overall set of aspects they encompass has largely become established standard. So I have here the principles I have used here is ethics, data privacy, data security, transparency, explainability, inclusivity, fairness, and accountability. Transparency is one of what I think it's one of the most important principles. It's not only an important principle in AI, but in the whole statistical production. So it means that the processes, decisions, and the use of AI system is open and visible to all stakeholders. It's not only about technical transparency MLOps can provide, but it's also the organizational transparency. It's clearly communicating how AI is governed by whom and under what rules. It includes also stakeholders' access to relevant documentation, how the statistical office has used AI in producing data, and why this matters. It enables trust and fairness. And again, I'm repeating now, I recognize now, technical transparency alone is not enough. The stakeholders, they also must understand the context and scope of AI use. So real transparency then includes both technical clarity and organizational openness. AI should also make fair and unbiased decisions. And fairness means that predictions and decisions must be equitable and free from discrimination. And fairness applies across the whole AI lifecycle, from training the model to output. And how do we achieve this fairness? It requires really careful attention to the training data. We all know that biased data produces biased results. Tools for bias detection. Fairness isn't one time. It requires continuous technical checks and monitoring, and also ethical reflection. And why transparency and explainability matter, because fairness loses meaning if experts and stakeholders can't understand AI decisions. Explaining how decisions are made builds trust and accountability. And again, generative AI brings really big extra challenges. Outputs generative AI makes, they are not always very traceable. and not traceable to specific training data, although they are open access models, but it's impossible to go through all that data there has been used in training that model. And that makes bias detection and explainability really hard. And I would say it's quite often even impossible with generative AI. Accountability means that we have clear responsibility for decisions AI makes. And who is responsible? We have to define ownership. Who ensures the quality and reliability AI-assisted data at each phase of statistical production? Can we trace and verify? Yes, AI models and dataset must be documented and auditable. It must be clear how the data was formed and how the decisions were made. And data production must follow regulations and also align with ethical principles of official statistics. But the final responsibility is a big question. And NSOs must ensure that the data is suitable for decision making and research and does not carry hidden risks or misinterpretation. So NSO is responsible. Now, at the beginning, I had these 3 roles there, and it's quite clear that with the supportive and collaborative AI, there's this human in the loop, and human oversees the result and the impact of AI and is responsible, and the responsibility lies with that user. But then with autonomous AI, it gets a little bit more difficult. The person using or triggering it is not responsible. So rather, the responsibility lies somewhere with those who have generated the service and authorized its deployment. So this is not that simple anymore. Ethical considerations with AI, they must be core part of AI development and use. And yes, not an afterthought. And what ethical AI means, it means that AI must respect societal values and avoid harm. And it should not unfairly benefit or disadvantage specific groups. And how do we ensure that our AI is ethical? It requires really clear governance. Who is responsible for ethical compliance? And requires accountability across the whole AI lifecycle and requires ethical impact assessment, not just that technical validation, and guiding ethical principles, doing good and not doing harm, and respecting human agency and promoting fairness and making things understandable. One of the perhaps well-known principles is data privacy and data security, and that's really protecting personal data. And it's for statistical offices, it's quite important thing, and also it's essential for maintaining public trust. AI systems, they must comply with laws like GDPR, but they also must protect sensitive data using strong technical and organizational safeguards. Communicating clearly how data is handled helps earn and keep that public trust. It requires regulatory compliance, technical safeguards like usage of encryption, secure storage, access control, pseudonymization, synthetic data, and so on. Ethical principles in practice. It's conducting bias audits, ensuring transparency in how the data is processed and used. So privacy and security, they are not just legal obligations. They are fundamental to trustworthy and responsible AI. And again, they are fundamental to statistical offices to remain public trust. And then explainability. How do we achieve it? We have tools and methods that help technical and non-technical people understand the model's reasoning. We have common methods for explainable AI like LIME and SHAP, but deep learning and large language models are much harder to explain. Decisions in large language models, they rely on such a complex patterns that are really hard to trace, and traditional tools like LIME and SHAP, they often fall short, and that makes explainability and therefore trust also harder to achieve in high stakes uses. Inclusivity, it's not as a principle in all the responsible AI classifications, but I always want to have it as a separate one because I think that it ensures somehow equal representation in the whole AI development and helps prevent unintended exclusion or harm, and build systems that reflect the needs of broad and diverse population. But why it's difficult, and especially in generative AI, because generative AI models often learn from biased training data. So we have then also quite often biased output. This can lead to unequal treatment or exclusion of certain groups. And inclusive public sector AI is really important because we have to design services usable by all citizens, regardless of technical skills. So now I've gone through, checked all the principles of responsible AI, but then a couple of slides about implementing responsible AI and checking a little bit about the AI regulation side. So implementing responsible AI is not a theory, it's really a commitment to action. It ensures the AI-supported statistics that they are transparent, fair, accountable, secure, ethical, and so on. By actively committing to these principles, statistical producers can strengthen the public trust and increase the reliability and credibility of outputs, and ensure AI enhances rather than compromises statistical integrity. So without responsible AI, I think there's a higher risk of bias, misuse, and loss of credibility. And it will undermine evidence-based policymaking and public trust in official statistics. And then another piece in this AI puzzle, AI regulations, they embed key responsible AI principles like transparency, fairness, and data privacy into formal legal requirements. When responsible AI is a voluntary and internally defined while the regulations bring external enforcement and industry-wide consistency. So most AI laws are motivated by responsible AI concerns, such as avoiding bias and ensuring explainability. Together, I think they complement each other. So responsible AI builds culture and values, and regulations ensure compliance and accountability. And examples from practice, all big companies, tech companies like, and for example, Microsoft and Google, they apply also responsible AI principles, even beyond the laws require, just to strengthen the public trust and ensure ethical AI development. About the AI regulations, that's our module 2 actually. Just 2 slides about this. We have 2 broad approaches. We have regulated AI, some specific AI laws such as this European Union EU Act, and then we have in United States federal and state level AI legislations, and in China we have nationally developed AI regulations, and then we have existing laws applied to AI. Most of the countries rely on general laws to regulate AI. Including Australia, Canada, New Zealand, and so on. But definition of AI varies a lot. We have, for example, OECD definition, EU's AI Act, SNA, and balance of payments, US Census Bureau, and this definition, they vary a lot, and it makes things a little bit difficult sometimes. EU's AI Act, the systems are classified into different risk categories based on how likely the risk is and what the AI systems is intended to be used for. So I see there's a problem related to the definition of an operator in the AI Act. So the use, for example, Statistics Finland the use of AI is likely to fall into the low or minimal risk category, because Statistics Finland itself does not make decisions or take actions based on the data it produces. The actual decision maker who uses AI generated data from Statistics Finland as a basis for decisions may not be using AI themselves, and therefore activities may not fall under AI Act's definitions of an AI operator or user. So this creates a regulatory blind spot where the influence of AI is significant, but no single actor formally meets the definition of AI user operator. I've forgotten the term in English under the regulation. So just because something is legally permitted for statistical offices, it does not mean that it's ethically acceptable, especially from the perspective of official statistics. So even though these regulations don't force us to do things or avoid doing things, I think we have to be more look at this more from the ethical perspective. So once more a picture, perhaps there should be one more picture before the risks identified, that AI better understood, and then AI's risks identified, guardrails built, and responsible AI adopted. That's the process it should go. And then short introduction to other modules of this advancing responsible AI. So we have total of 8 modules, with this introduction serving as the first one. The different modules, they cover various aspects of responsible AI and explore strategies and guardrails for more effective risk management. Additionally, Advancing Responsible AI seeks to consider the role of AI regulations in ensuring responsible statistical production. The other modules are ethical principles. This module will likely feature a lecturer from academia. The next one, which will be quite soon, is actually AI operationalization, MLOps and LLMOps. It's where MLOps provides guardrails in various forms. And then we have the explainability and data privacy and security. And then we have case studies. And then we have this continuous learning and adoption that covers, provides practical advice and tips for some kind of ongoing development. The dates for the other modules will be announced as the webinars are finalized. So after holiday season, which in Finland is quite long, but somewhere in the autumn, the third module will be ready. Thank you. That was the last slide.
Thank you, Riitta, for this very great presentation. So in the meantime, while you were speaking, there were already a couple of questions coming in the chat. Maybe while I try to switch on the cameras and the microphone, maybe Panya, you can try to do that if I don't manage to do it. So maybe as a starter, let me ask you one question first, and then maybe somebody can come in live. There is a question from Sharubil Ibrahim Sharif. Sorry if I mispronounced the name. Can you give a real world example how you used AI in a statistical field in official statistics, and what was the reason for using AI, and was this feature accessible to the public, such as journalists or other users? Yeah.
At least at Statistics Finland, we have used AI in classification. We have generated our own AI models in quite many classification cases. And what was the reason for using? I think when we use AI-based classification, for example, we don't need that much human hands anymore, because going classification with text-based classification done manually, it's really hard work and needs a lot of human hours, work hours.
Yeah, thank you. So exactly. So AI is often used to reduce basically the human interaction or the human decision, right? To make the processing of statistical information more efficient. So I have now enabled the microphones and the cameras. So if you have questions and you would like to ask them live, so maybe raise your hand and then we can give you the floor. And I saw that there was a question by Tzu. Again, sorry if I mispronounced the name. Do you want to come in, or should I read out the question? Yes. This is not. No. So the question was, do you have an example use case for a technical or organizational guardrail? Maybe we can continue with that question. Thank you.
Yeah. Well, that's a good question, because that's the thing I love because we have been building our infrastructure, technical infrastructure for machine learning for some years, and we have managed to somehow finalize that. And when we have the infrastructure there in cloud, we 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 also use such a components that we version everything, so everything is reproducible, and I think this is really one of the technical guardrails, one of the best. But of course, I always have to remind that when we come to generative AI, we are not that far. No one is that far that we could say that all the technical guardrails are there.
Yeah. There's another question by Tracy Kugler. Tracy, not sure if you want to come in yourself. Otherwise, I can read out the question for you.
Hi, yeah. So my question is around the kind of tension between transparency and how hard it is to really understand where the output is coming from in a lot of AI systems, and thinking about how you kind of manage that tension or draw that line between when and how it's responsible to use systems where you can't always fully understand where the output is coming from, and if there are circumstances where you should just avoid using those systems entirely.
But do you actually mean more now explainability than transparency?
Both, I think.
Yeah. Transparency, for example, with the models, with self-trained models, it's quite easy actually when you have the infrastructure and the processes. But the explainability, I think it's always much more difficult. So.
Yeah. Is there actually a way to, for, let's say, if you use, for instance, a large language model to identify and classify things, right? And you haven't trained that system yourself. You use something that you basically buy from somewhere, which you use through an API, and you don't really know what's going on in that black box. How do you deal with that? How do you explain that to the users of official statistics?
Yeah, and at the moment, there are some, for example, some evaluation agents. We are not using them. We are just starting to use them. But to evaluate the output of large language models, that's really challenging. And I think no one at this earth has really solved the problem. But to use large products where large language model is used in that way, that there's still this human oversight, that I think it's still somehow acceptable, and can be somehow, let's say, there's this human that's evaluating the result. But as an autonomous AI, I would not use large language models. And that's what the academia says all the time. And there's this other hype that goes there in the private sector, that you can use large language models all over. But when you know and understand it more, you say not yet.
Okay.
That makes sense. Thank you.
I see in hand up that's Amra Noor. from UNSC. Please, Amrul, come in.
Thank you, Alex, and thank you, Riitta, for the presentation. Your presentation as a whole and the modules as you presented them, the upcoming ones, I mean, they are more focused on having a solid, obviously, governance structure and governance framework for the AI to mitigate its risks and so on. And this is absolutely obviously needed. I'm just thinking also of the opportunities of the AI, especially for countries in the South who have very limited capacity. And that would be mostly in the support AI and the kind of, at best, collaborative AI fields, maybe. All right. And my question, do you have like a breakdown, or did you make like a breakdown of the tasks in the production cycle of statistics where either supportive AI or collaborative AI could be used?
Yes, me and my colleagues, we have worked through the GSBBM quite many times, where the AI could be used and in which role, and yeah, but it's something that really has to be. With last time when we did it, that was nearly a year ago, and it's not. It has to be updated because the AI is changing so quickly and new things arriving that it's, yeah. But I think it should be really produced such a GSBBM AI map where you can use it and in which role.
Thank you. I see there's another hand up by Zuzu. Please come in. I think we cannot hear you. Maybe your microphone is muted on your side. Can you try again? No, we cannot hear you. Sorry for that. Yeah, maybe write the question into the meeting chat. Sorry for that. I will try to enable your microphone in the meantime. Yeah, there were also some questions from the registration form that we maybe can take in the meantime. So we talked already about the use of LLMs, so large language models, and there's a question whether you have considered the practical use of local large language models. So I guess large language models that are running on your local machine. And if they have particular advantages that they might have in terms of energy impact on the one hand, but also in terms of data confidentiality. Maybe you can elaborate a little bit about that. Thank you.
I easily start thinking about DeepSeek and R2 when we are talking about locally running models, large language models locally. And I just read an article this morning about warnings of this. So yeah, I'm not a very big fan of this running these models locally. So I still think that common infrastructure for this is the best one, although it's environmentally sometimes a little bit not so positive thing.
Yeah, thanks. Zuzu, you want to try to come in once more? Let's try once more. No, sorry, not working. Okay, so So there was a question about the use case for technical and organizational guardrails, and Susu wanted to ask whether you have recommendations for real-time monitoring and accountability structures that an organization can implement for guardrails in practice. So maybe you can answer that.
Yeah, we have been testing several AI monitors. The problem is that some of them are really good, but they are also very expensive. So we have now last week decided that we start picking up proper algorithms from GitHub and start building the monitor by ourselves, because they quite often they are six-figure numbers. You have to pay for the license per year, so it's really expensive. So and with the accountability, I've been discussing with the top management, and we are trying to somehow build some kind of accountability structure that everyone would understand where their responsibility lies, but we are not ready yet. But I think it's really something that has to be done quite quickly before there's AI there, here and there running, and we are not at all aware who's responsible for the results, and perhaps when we start putting out totally biased figures. So yeah.
Thanks. There was also a question by Caroline Wood, who was saying, okay, so recently we were told that OpenAI's smartest AI model disobeyed direct instructions to turn off and even sabotage shutdown mechanisms in order to keep working. So the question there was, can guardrails really be built? Is it safe?
Can guardrails be built, and is it safe? Is that the question? Yeah.
Yeah. So can guardrails really be built? Is this something that works? So that was kind of the question there.
Yeah, I can think about, for example, data privacy and security principles. I'm responsible for that module also, of presenting that module also, and it's been really hard to find anything new. I mean, we have already this anonymization, pseudonymization, and so on, and it's not that easy. I mean, yeah.
Okay.
It's the infrastructure and the organizational regulations and all these very familiar old things that when you combine these, I think then you can build some kind of guardrails. But I recognize that it's difficult to already talk with our IT people, because they don't, although they are gurus in cloud things, for example, but they don't understand what the AI brings when you put a large language model into the cloud. What's the combination then? It's difficult.
Yeah. There's also a question by Christophe Bontemps. Christophe, you want to come in?
Hello, good evening. Thank you for this very stimulating presentation. It gave me a lot of questions. I have now more questions, I think, after this presentation than before. So I think this is a sign that it was really, really good. I have some sort of provocative question. We always talk about explainability, transparency, and reproducibility in black and white terms, while it seems that there are lots of gray zone already, in a sense that, I mean, it's difficult already to explain, and it depends once again to whom, some models, right? We are using imputation. We're using some machine learning models inside the NSO. I'm not sure we completely understand and we can fully explain already what is going on when you classify something as, you know, different classes. So the question I have is how we decide the level of gray is acceptable, and who decide that? Should it come from the law, where somebody has the right to know why he has been classified as in a category, or should it come from a technical side? And what is the role of NSO here? How to define this level? It's a big question, I imagine.
Yeah. It's really is, yes. Yeah, I think we are mainly all the time nearly at that gray zone, I think. Because for me personally, explainability and all these methods, they are really difficult to understand. I'm a computer science. I say that every time when we start talking about those methods. But who should decide what's the right level? I think this is something that has to do with the AI governance as a whole, which is much more than just this implementing responsible AI. And I think it comes there. We are at the Statistics Finland at the beginning of that journey, just trying to identify what kind of governance structures we need. But what I think it's important that our stakeholders, we can tell something if they ask. We cannot answer that. It's AI that produces these figures. We don't know how and why.
Yeah, you should trust your models, right? And this is probably the best answer you can say. Right? You're trusting because there's human in the loop. Right?
Yeah.
Yeah, thanks. So I wanted to give another chance for people to ask questions. So please, if you want to come in, either raise your hand or type it into the chat. That's also fine if you cannot speak. And I see one more question here from Caroline Wood. Caroline, you want to come in?
Me, I can just read my question.
Yeah, that's fine.
It's a question I'm starting to ask myself in the past few months, because it's maybe ethical, but if we combine the risk of AI to disobey human orders and with its environmental impact, and we see more and more that AI is diminishing the need for human work. You said it yourself, Riitta, less words, less hands involved in the statistical work. So is it worth this risk on a large scale to use AI at all? Why is humanity embarking on AI? I know it's a bit of an ethical large question.
I think we just have to at least, it's very clear at Statistics Finland, we have to produce statistics with much less people. So there are other things that we should be thinking also, but that's so clear at the moment. So it's the tool we can reduce the amount of people producing statistics. It does not sound very nice.
I guess, I mean, in addition to, well, of course, you have efficiency gains through the use of AI, but I guess you would also have maybe a better quality of your statistical output in principle, right?
In principle, yes, but the monitoring and all this infrastructure, it has to be really good. That more you use it, more you have to evaluate and monitor the results. And with large language models, these things are not ready, so the expectations are a little bit too high at the moment. So I said in some meeting last year that when do I expect, for example, this agentic AI is there in statistical production? I said after 10 years. So it's not there. Yeah.
It's all right. Okay, there was just a comment from Christina. Goodness, I'm so glad someone just asked that question, so confirms this. So last chance to ask a question now. Otherwise, if there is none, so really last chance, raise your hand. Okay, I don't see any. Well, in that case, I would like to ask everyone, if you can, please put your camera on for a few seconds and also maybe your microphone, and give Riitta a round of applause. Please join me in doing that. Thank you, Riitta. Thanks so much.
Thank you so much, Riitta. Appreciate it.
Thank you, Riitta.
Thank you.
Thank you.
Thanks so much.
Thank you.
I just want to say one more thing before you all go. So we will have our next webinar also related to AI. It's on the topic of AI operationalization, MLO ops and LLM ops on the 17th of June. So please sign up for that and join us next time. I will put the registration link in the chat. Thank you.
Thank you. Bye.
Thanks, Riitta. Thanks, everybody. Bye.
Thank you.
Thank you. Thank you
so much.
Bye-bye, everyone.